The phrase net force is used in a lot of places in physics, and that's because it's very crucial to how we view motion and interactions. But what does net force really mean? I'm Ben, this is Physics or Bust. In physics, anytime the word net is used, it means the sum of all contributions to a quantity, whether it adds to it or subtracts to it. Force in physics is a vector quantity. So when we're looking at net force, and we're summing up, adding up all the vectors of force that are contributing to an object, then we're looking at magnitudes and directions all adding up using vector addition. And if you want to know more about vectors, you can check into this playlist here. I also have a video specifically about vector addition if you click into this one. Force in physics is a vector quantity since it has magnitude and direction, which means that when we do an addition, a net force, we have to use vector addition. It's not just adding and subtracting the magnitudes, it's taking the direction into account when you do that addition. So that's what we call vector addition. So looking at a net force, we have to include every force being exerted on the object or chosen system by all the surrounding objects that have an effect on that object or system, whatever that system may be. When we look at a system or an object, say a box on a ramp, all right, we don't have to look at the interactions between the molecules inside the box. So a box itself is made up of a lot of different molecules, and they're all connected to each other, and there's interactions that happen. But all of those are considered internal interactions. So the forces actually end up just canceling each other out. So those ones we don't actually have to look at. So if we look at a system where you have a box on a ramp, there's going to be a few different forces that we need to be looking at specifically. One, there's the force of gravity. Two, there's the force perpendicular to the plane of the ramp that the box is on. That is called the normal force. There's also the friction force from the box sliding down the ramp. And there's also a friction force from air. A lot of times the force from air isn't going to be big enough to include. It's going to be what we call negligible, able to be neglected or put aside and not thought about, and still get a really good representation of the total force, the net force that's acting on the object. So if we're looking at a box on a ramp, we have the force of gravity pulling downward. We have the normal force, which is the force from the ramp pushing perpendicular to the surface of the ramp onto the box. We have the friction that's happening between the ramp and the box, going up the ramp, assuming that the box is sliding down the ramp. And we have the friction force of air. And those friction forces always go in the exact opposite direction of the motion of the box. For determining net force, it does matter what system you're choosing. For instance, if you have two people both on skates on ice and they push each other apart, let's say that you take the system of just person one. With that person one as your system, you're going to have the force of gravity, the normal force from the ice pushing up, and you also have the force from person two pushing on person one. And then there's also the force of air resistance as they start moving. But on the other hand, if you choose the system of both people, person one and person two, as your system, then the interaction between person one and person two pushing on each other cancels out because they each are pushing with the exact same size force in exact opposite directions. So then the only forces to look at would be the force of gravity on both of the people, the normal force on both of the people, and any force of friction on each individual person. But that force of them pushing on each other, because your system is both people together, those forces cancel out, so they don't need to be included in your net force. So in determining net force, the one big question to ask is, what is the system that I'm finding the net force for? I hope that helps you. Go ahead and put your comments below. Don't forget to like and subscribe, and remember, keep asking questions. I'll see you on the next video.